Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, how are you doing? I hope everything is well with you. Welcome to another video from your channel Easy Chemistry for All. This is Mr. Muad. And before we start, please share and subscribe if you hadn't done so. Put a like, okay guys, because this will help the channel grow and become more popular so that many more students can hopefully benefit from these videos, inshallah. So now we are in module 17. We are still in the chapter of acids and bases, we are in the chapter of acids and bases. And we are in lesson 4, neutralization. Okay, so neutralization, if you remember from your previous studies, neutralization means acid plus base will result in water, right? So it comes from neutral. Okay, so it's a reaction between acid and a base, and we'll have a look at that. So what is the learning outcome, or what are the learning outcomes of this lesson? First of all, write chemical equations for neutralization reactions, okay, and explain how neutralization reactions are used in acid-base titration, okay? All right. So this is the main idea, guys. In a neutralization reaction, an acid reacts with a base to produce salt, which is an ionic compound, and water. إذا عندي أسيد حمض تفاعل مع بيز قاعدة الناتج راح يكون مركب أيوني زائد المي. This is always true, okay? And we'll have a look at that. So this is just to stimulate your thinking. Whenever you have a heartburn or حموضة, you take a medicine or you drink some milk or you drink something. You have something to reduce this burning, right? So what you actually have bases to neutralize it, okay? So if you drink an antacid اللي هو مضاد حموضة يكون فيه هاي المادة. This is a base. والأسيد الحرقة اللي عندنا HCl. So they will react together, okay? And this reaction will be neutralization reaction. So it's a reaction in which an acid and a base in aqueous solution, يعني الحالة AQ, react to produce salt and water عشان هيك تخف الحموضة أو حرقة المعدة, okay? So we already talked about neutralization reaction. And what is a salt? I told you that the salt is an anionic compound made from a cation, positive ion, that comes from the base. So the positive ion comes from the base, and the negative ion comes from the acid. So for example, in here, this is the neutralization, a reaction between MgOH2 and HCl. This is a double replacement reaction, guys. درسناه زمان. يا إما درستوه السنة اللي فاتت يا إما درستوه السنة اللي قبل اللي فاتت. Double replacement reactions. We'll have a revision on it. Basically, what I'm trying to say here, you are going to have water in the product, right? And then you will have MgCl2. Now, MgCl2 is an anionic compound. ال Mg plus 2 اللي هي البوزيتيف جاية من وين؟ من البيز. It's coming from the base here, right? And the Cl minus is coming from the acid. This is what I told you here. The positive ion comes from the base and the negative ion comes from the acid. So this is Mg plus 2 and Cl minus. So the positive ion comes from the base, the negative ion comes from the acid. Alright? So double replacement reactions, you studied this in probably grade 10, if I remember correctly. Double replacement reactions, guys, are reactions in which ions switch places. Okay, so you have compound and a compound, and they will switch places. The B will go with the X, and the A will go with the Y. استبدال ثنائي. Okay, so how do we do it? You have calcium here. You need to break down each compound into the positive and the negative ion. Positive and the negative ion, and then the positive ion goes with the negative ion here, the positive ion goes with the negative ion here. So Ca plus 2 and Cl minus give you this. H plus مع OH minus gives you water. And this is a neutralization reaction. ليش؟ لأنه this is a base فيها OH. This is an acid. Okay? This is just for you to remember the charges of each element. لو تتذكرون أنا Ca هنا حطيتها plus 2 صح؟ لأن Ca موجودة في جروب 2 فالcharge حقها plus 2. Okay? Cl الcharge حقها minus 1 لأنها في جروب 17. That's why I added minus 1. H دائما تكون plus 1 لأن نعرفها plus. Okay? As you can see here, it's always plus. And OH minus high is actually a polyatomic ion. Okay? It's a polyatomic ion. So you need to revise these things, guys. You need to revise them. Alright? And regarding the double replacement reactions, this is how we write double replacement reactions. هذه الguidelines حق double replacement reactions. And these are examples of acid-base reactions, which actually were how can I say it? Which actually you studied before, all right? So you have different acids and bases, and then you will get acid and salt and water, acid base, salt water, acid base, salt water. And if you want to learn more about it, guys, إذا تحبون تسوون مراجعة عليها، روحوا لهذا الفيديو في القناة اللي هو chemical reactions, reaction aqueous solution. روحوا لهاي الدقيقة وشوفوا part 2. So only part 2. هذا فيه مراجعة شاملة على الacid base reactions اللي هو double replacement reactions. How do we write ionic equations and so on. Okay? So this is the neutralization reaction. And remember that sometimes we write H plus as H3O minus. So the net ionic equation for the acid-base reaction is H3O plus, the OH minus gives me 2H2O, or H plus, so OH minus gives me H2O. كلاهما صح. Okay? So what are the products of a neutralization reaction? Of course, it's going to be salt and water. Okay? اللي هو يكون طب والreactants إذا سألنا على الreactants reactants. The reactants are acid and base. So these are the reactants, guys. Alright? Now, how to write net ionic equations for KOH and HNO3. نفس ما قلت لكم إذا تحبون مراجعة على هالأشياء وناسينها روحوا لهذا الفيديو وطالعوا part 2 يتكلم لكم على الأيونيك equations, double replacement reactions and so on. Okay? So now you have a reaction. Alright? So now you have a reaction. Alright, guys? Now you should know that this is a base and this is an acid. And it is a double replacement reaction. فاحنا دائما نعرف انه لانه هذا acid base reaction دائما في البرودكت راح يكون عندي مي. صح؟ المي جايه من وين؟ من ال H وال OH. صح؟ يعني المركب الثاني اللي هو salt is going to be K and NO3. be KNO3. كيف ان احنا نسويها اصلا؟ اصلا نفصل كل مركب الى ايونات. اوكي H plus NO3 minus. H goes with this and the K goes with this, and then you have your product. Now we have something called complete ionic equation اللي هو any substance that has AQ we write it as positive and negative ion. هذا مشروح في الفيديو اللي قلت لكم عليه في اليوتيوب. اوكي في الدرس اللي هو درس reactions in aqueous solution. So you write K plus OH minus plus H plus NO3 minus. كل مركب فيه AQ فككناه إلى أيون موجب وسالب. Then you have the arrow. K K plus NO3 minus plus H2O. هذا ما فككناه لأنه مش AQ. So it happens for AQ only because it means it's dissolved. Now to write the net ionic equation, so the net ionic equation, very simple. Just look here, you'll find a similar ion in the left and right side. You'll find a similar ion in the left and right side. Just remove them. نكنسلهم. You will get H plus OH minus gives me H2O. هذه هي النت ionic equation. نفصل الأيونات المتشابهة في اليمين وفي اليسار ونحط الباقي. Or you can write it as H3O plus OH minus gives me 2H2. كلاهما صح. It's either this one or that one. Okay. So basically now what we want to do, we know that the acid-base reactions form salt and water. But if you have an acid or a base with a known volume and unknown concentration, molarity, how do we find it? Okay? How do we find the concentration? إذا عندنا acid أو base معروف الحجم حقها وما نعرف الconcentration، ما نعرف المولاريتي. How can we find this concentration? So we use something called acid-base titration, المعايرة, which is a neutralization reaction. Okay? So what is titration? Titration in chemistry في الكيمياء هي طريقة نحدد بها الكونسنتريشن حق مواد ما نعرف الكونسنتريشن حقها. It's a method for determining the concentration of a solution. How نخلي هاي المادة تتفاعل مع مادة ثانية. And this other substance has a known concentration. Okay? So using solution of known concentration to determine the concentration of another solution. Meaning, imagine I have A, I don't know the concentration of A, right? But I have the B, I know its concentration. So I will do A plus B, I'll make them react. في reaction هنا يصير، صح؟ هاي الطريقة نقدر نحدد بها concentration of A. إن إحنا نخليها تتفاعل مع مادة ثانية اللي نعرف concentration حقها. Okay? So in here, this is the acid-base titration setup. Okay? هاي هي الطريقة اللي إحنا نستخدم فيها acid-base titration to determine the concentration of an unknown solution. So here we have a beaker. هذا نسميه beaker وهذا نسميه burette. في البيكر يكون عندي الانالايت. The analyte can be acid or a base. This is the one that I want to find the concentration of. So I don't know the concentration of this one, but I know the volume. So I'll make it react with another thing called titrant. We put it in a burette and we can open this to add drops here. And this is a pH meter here. So in here we know the concentration and we know the volume. So we know the concentration and the volume of this. We don't know the concentration here, but we know the volume. ونخليهم يتفاعلوا. Okay? So basically what I do here, I make a graph of pH and this is the volume added. من مين؟ الvolume added of this one. لأن كل شوي أنا أفتح هاي أضيف drops وأسجل كم ضفت. So وكل مرة أضيف I calculate the pH. So I'll have like points, okay? Like points, a lot of points. Alright? So this is basically what we talked about. How is it performed? So a measured volume of acidic or basic solution of unknown concentration is placed in a beaker and the initial pH is red. اللي هو شفناه هنا. Okay? A burette is filled with the titrating solution of known concentration. This is the standard solution, the titrant, which we saw in the burette in here, right? And after that, measured volumes of the standard solution اللي هو titrant, okay, are added slowly to the beaker. يعني نبدأ نضيف شوي شوي drops ونسجل ال pH كل شوي. Okay, the pH is read after each addition ألين ما يطلع عندنا curve نفس ما قلت لكم. يطلع عندنا curve مثلا هني الفوليوم وهني ال pH until we reach the equivalence point. شو هي ال equivalence point؟ هي ال point in which the moles of H plus will be equal to the moles of OH minus. هذه من الأسيد وهذه من البيس. كيف نعرف ان احنا وصلنا للايكوفالنس بوينت؟ the color changes. نضيف شيء اللي هو يخلي الكلر change when we reach the equivalence point. Okay, so these are the graphs that I told you guys. So this is the volume added. Okay, نبدأ نضيف الفوليوم والPH قاعد يتغير and we record these things until we reach the equivalence point. هني الكلر يتغير, the color changes, and in here as well the color changes. Okay, so in each titration curve هني a steep rise in the pH of the solution indicates that all H plus from the acid have been neutralized by OH minus. هذه هي steep. So steep, this is steep. يعني هاي المنطقة معناها انه ال H plus كله اتفاعل مع ال OH minus اللي ضفته. Okay, so this is a titration curve of a strong acid and a strong base. The initial pH is 1, as you can see it here. This pH initial قبل ما أضيف أي شيء. And وأنا قاعد أضيف ال OH NaOH ال pH قاعدة تزيد لأني قاعد أضيف بيز صح؟ وقاعدة تتفاعل مع ال H plus. يعني ال H plus قاعد ينقص. لما ال H plus ينقص ال pH قاعدة تزيد. You keep going until you reach the equivalence point. ال equivalence point هاي يحصل زيادة مفاجئة في ال pH نفس ما نشوف هنا. This is the equivalence point. After the equivalence point, ال pH قاعدة تزيد شوي شوي. Okay, because I'm adding more OH minus now. Alright? And this bromothymol blue هذا مادة تغير لونها عند ال equivalence point. And the equivalence point here is 7 because we have a strong acid and a strong base. Alright? Now, what if we have weak acid and a strong base? So this is methanoic acid. Okay, this is a weak acid. تمام؟ قاعد أضيف له NaOH. That's NaOH. The pH initial, ال pH الأولية is actually 3.5 مش 1 عشان شي هو weak. The equivalence point now, you will keep adding same thing. The equivalence point is actually between 8 and 9. It's not 7. Alright? So it's between 8 and 9. And phenylphthalein changes color at the equivalence point of a titration for weak acid and a strong base. فإذا عندنا weak acid and a strong base, we choose this one, the indicator, هي الصبغة اللي تقول لنا متى وصلنا إحنا ال equivalence point. And we'll talk about it shortly, okay? So, what term refers to the point in a titration when the concentration of H plus is equal to H minus, OH minus? This is called the equivalence point. Okay? So, in conclusion, guys, you might think that all titrations must have an equivalence point of 7. مش إحنا قلنا لما ال OH minus يساوي ال H plus معناها I am neutral. يعني ال pH المفروض تساوي 7. So that's the equivalence point, right? The equivalence point لازم تكون دائما 7. Like water. But that is not the case. Sometimes in some titrations the equivalence point will have a pH less than 7 and sometimes the pH will be greater than 7. Because remember, in the acid plus base reaction, what do I get? I get salt plus water. احنا إلى الآن ما تكلمنا على هاي السولت. هاي السولت تحدد لي إذا equivalence point أكبر عن 7 أقل من 7 أو تساوي 7. So these differences occur because of the salts which we'll talk about later inshallah. And we already talked about the equivalence point, which is the point at which OH minus equals H plus. And we'll see what do we mean by the endpoint. The endpoint is the point in which the indicator used in the titration changes color. مش احنا نقعد نضيف لين ما الكلر يتغير. لما يتغير الكلر هاي نسميها الاند بوينت اللي هي helps us find the equivalence point. ساعدنا ان احنا نحصل الايكوفالنس بوينت، لانه احنا ما نقدر نعرف الايكوفالنس بوينت الا من خلال التغير في اللون. اوكي. So acid base indicators الصبغات اللي هي تغير اللون. So chemists often use a chemical dye يعني صبغة to detect the equivalence point in an acid base titration عشان نعرف شو هي الايكوفالنس بوينت اللي شفناها في الكيرف. اوكي. شوف هني اللون يتغير صح؟ فهاي هي الايكوفالنس بوينت. So what are these things? These things are called acid base indicators. So chemical dyes الصبغات الكيميائية whose colors are affected by the acidic and the basic solution يعني بال pH. الصبغات اللي تتغير لونها بتغير ال pH are called acid base indicators. And the point at which the indicator used in a titration changes color يعني هو يكون عنده لون معين. لما نبدأ التجربة حقت التايتريشن لما نوصل الايكوفالنس بوينت اللون يتغير. لما يتغير اللون we call this point the end point. So it is important to choose an indicator that will change color at the equivalence point of the titration. يعني لازم نختار عندنا كثير من الانديكيتورز. لازم نختار انديكيتور اللي راح يغير لونه عند الايكوفالنس بوينت. اذا ما تغير اللون عند الايكوفالنس بوينت ما في فايده من هاي الانديكيتور، ما راح نعرف شو الايكوفالنس بوينت. اوكي. So these are some acid base indicator. مثلا الكريستال فايولت لونه يكون اصفر، بعدين عند الواحد يستوي اخضر، فوق الواحد قريب الاثنين يستوي ازرق. هاي هي البي اتش، الصفر والواحد والاثنين والثلاثه هاي قيم البي اتش. اوكي. So remember bromothymol blue here no color. Okay, sorry, here no color لكن يبدأ يتغير اللون وين؟ عند 7. Okay, sorry, in here you'll start having change in color. So the color changes, it was something here and then changes at 7. Okay. وفي عندنا universal indicator اللي هو لونه يتغير عند كل pH معين. شوف كل pH فيه لون مختلف. فينول فيثالين اللون ما في لون لكن متى يتغير؟ يتغير ما بين 8 و 9. See, you have color now, but before you don't have anything. That's why in here look no color. لما نبدأ نوصل ال pH ما بين 8 و 9 يبدأ لونه يظهر اللي هو اللون الوردي أو الأحمر. As you can see here. See, يبدأ اللون الوردي يظهر ما بين 8 و 9. Okay. So now, what are the calculations? اتذكروا إن إحنا we were trying to say how to find the concentration of an acid or a base. So molarity from titration data. الحين راح نستخدم الداتا من التايتريشن من الكيرف to actually do some calculations. So a volume of 18.28 milliliter of standard solution. الستاندرد اللي هو titrant اللي نعرف الكونسنتريشن حقه. هذا الكونسنتريشن of 0.1 molar NaOH was required to neutralize 25 ml of a solution of methanoic acid. What is the molarity of methanoic acid? So basically we know the concentration of NaOH equals 0.1 molar. أنا بسميها المولاريتي. أوكي، المولاريتي of NaOH equals 0.1 molar. والvolume of NaOH equals 18.28 مل. والvolume of methanoic acid is equal to 25 ml. هو شو يريد؟ يريد ال concentration of HCOOH. So this is the titrant أو اللي هو standard solution. والحين يقول لي شو ال concentration حق الأسيد. The first thing that you need to do, guys, is write the equation, the acid-base reaction. Okay, so when you write the acid-base reaction, you are going to get NaHCO minus plus H2. Okay, because in here what will happen, the Na will go with this and the H here will go with the OH here عشان تكون لي المي. صح؟ double replacement. This is the first thing that you need to do. Alright, so in the book, yeah, it's okay, that's the same equation. Okay, we'll see it, we'll see the book solution shortly. So the first thing that you need to do, so step 1, find NaOH moles. You remember that moles equals المولاريتي times الفوليوم. صح؟ So it will be شو المولاريتي of NaOH 0.1 times الحين هذا الفوليوم بالملي. صح؟ we should change it into liters. كيف؟ نقسم على 1000. so times 18.28 تقسيم 1000 لتر. وهذه 0.1 احنا نعرف انه المولر is actually mole over liter, right? So this one is also mole over liter. الليتر يروح مع liter and then you will get 0.1 times 18.28 and you will get 1.828 times 10 to the power 20 sorry times 10 to the power minus 3. Okay, mole NaOH. Now step 2, guys, step 2, find moles of HCOOH from moles of NaOH. نشوف المعادلة. Let's look at the equation. Sorry, I shouldn't have written minus here. That's wrong. لأن هذا مركب أيوني. My apologies. Plus H2. هل المعادلة موزونة؟ Very important. You should balance the equation. The equation should be balanced. So M1 NA 1 NA 1C 1C 3O 3O 3H 3H. So it's balanced. So now the coefficients, you'll find that the coefficients are 1 here and 1 here, right? لأن ال coefficients هني 1 and 1, so the moles of HCOOH will be 1 times 1.828 times 10 to the power minus 3 مول ضرب من المعادلة 1 مول HCOOH اللي هي هاي الواحد هني على 1 مول NaOH، وهذا المول اوف NaOH اللي هو هني. فنضرب المول اوف NaOH على ضرب ال coefficients from the equation 1 mole HCOH over 1 mole NaOH. NaOH mole goes with NaOH mole, and then you will get 1.828 times 10 to the power minus 3 mole of HCOOH. So now, what do we have now? We have the moles of HCOOH اللي هي تساوي كم؟ 1.828 times 10 to the power minus 3 mole. We want the concentration, we want the molarity. احنا نعرف انه المولاريتي تساوي المولز على الفوليوم in liter. And we know the volume of HCOH 25 ملي صح؟ So the volume of HCOOH equals 25 ml. لازم نحولها إلى شو؟ إلى لتر صح؟ اللي هو 0.025 liter. So the concentration of HCOOH أو اللي هي المولاريتي، الكونسنتريشن والمولاريتي نفس الشيء، يساوي the number of moles 1.828 times 10 to the power minus 3 over 0.025, which is going to be 0.07312 molar. Okay, guys? So this is exactly how we do the things. Okay? So the first thing عند التايترنت دائما يعطونا الفوليوم ويعطونا المولاريتي. Find the number of moles. المولز تساوي المولاريتي ضرب الفوليوم. نتأكد انه الفوليوم بالليتر. إذا أعطانا الملي نحول للليتر. Okay? You can do that. Or you should do that. Okay? Step number 2 نستخدم المعادلة عشان نطلع المولز حق اللي ما نعرفه. مين اللي ما نعرفه؟ الكونسنتريشن حقه HCOOH, right? So we'll find the moles from the moles of NaOH. نستخدم المعادلة نشوف الكوفيشنتس. هذا المول اللي طلعناه أول شيء نضربه في شو؟ في الريشيو between the coefficients. لازم الإيكويشن تكون balanced. So it is 1 mole of HCOH over 1 mole of NaOH. And it gives me this number. الحين step 3. This is step 3. عندي المولز وعندي الفوليوم. فالمولاريتي تساوي المولز اوفر فوليوم لان انا اصلا اريد اطلع المولاريتي من السؤال صح؟ So the moles divided by the volume بالليتر gives me the molarity اللي هي molar or mole per liter. Okay? بسم الله السلام عليكم ورحمة الله وبركاته. Hello everyone, I hope you are all doing well. So today we are going to learn about salt hydrolysis. Okay, this is chapter 4 on your Inspired Chemistry book, the acids and bases chapter, the last section, neutralization, and specifically page 147, which is salt hydrolysis. So I'm giving you this video just in case they made this included in the final exam. Okay, so you can watch it later. And yeah, it's only one page. So let's go to the learning outcomes. So we are going to define salt and salt hydrolysis. You know what's the meaning of a salt? It's an ionic compound. And we are going to identify whether a salt will be acidic, basic, or neutral. Okay, so what's the pH of a salt? When I put salt in water, an ionic compound in water, what will be its pH? How can we define that? That's what we are going to learn. So our main question is, are salt solutions acidic, basic, or neutral. All right. So for example, let's test 3 solutions of salts. Okay. One is for potassium fluoride, or KF. One is for ammonium chloride, and one is sodium nitrate. Okay. So how can we do that? We can just add some water to these salts and then measure their pH, or we can add a colorful or an indicator, sorry, like bromothymol blue. You already know about indicators now, and add a little bit of drops in each solution, and depending on the produced color, we can know what's the pH, and we can know if the solution is acidic, basic, or neutral. So in page 147, you have this image. Okay? So this image is from the bridge book, the white book. In your Inspire Chemistry book, you might have a different image, but the same colors. Okay? So let's see. Where's KF? So KF has a blue color. So let's go to the blue. Blue means the pH is bigger than 7, so it's basic. Okay? So this salt actually is basic. NH4Cl, this one here on the right, it's yellow, so it's acidic. The pH is below 7. What about NaNO3? It's green, so it's almost neutral. Okay? So what happens? Why do some salts, or why are some salts acidic while others are basic or neutral? This is what we are going to do, and the reason for that is salt hydrolysis. Okay, so what is salt hydrolysis? So many salts react with water. Okay, this is the main thing. React with water in a process called salt hydrolysis. Okay, so in salt hydrolysis, the anions, meaning the negative ions of the salt, because you know that salts are ionic compounds made from positive ion and the negative ion. Okay, so anions of the dissociated salt accept hydrogen ions from water. So salt hydrolysis can mean that the anions, or the negative ions of the salt, will accept hydrogen ions from water, or the cations, which are the positive ions of the dissociated salt, donate hydrogen ions to water. So accept hydrogen or donate hydrogen, meaning Bronsted Lowry acid-base reactions. If you remember, donate hydrogen or accept hydrogen. So salt hydrolysis, this process up here, can produce basic, acidic, or neutral salt solutions. Okay, so let's start with the salt hydrolysis that produces basic solutions. For example, potassium fluoride is the salt produced from a strong base and a weak acid. Okay, so strong base, this is very important, and a weak acid. For example, if you write the reaction between KOH plus HF, you know it's a double replacement reaction between an acid and a base, and the result will be KF plus H2O, right? So this KF here is the salt. Now if we put this salt in water, it will break down into a positive ion and a negative ion. Now one of these ions will react with water. Okay, have a look. So the K plus ions don't react with water, so we will not touch the K plus, but F minus is a weak Bronsted Lowry base. Okay, so there will be an equilibrium with water. There will be an acid or a Bronsted Lowry acid-base reaction. So the F minus is going to accept an H from H2O. So it will be a base, and the H2O here is an acid. And look what is produced in the products. It's OH minus. So because we have OH minus, the solution will be basic. So the pH is going to be greater than 7. That's why in the image we saw before, we found out that the
that KF is actually, the solution of KF is basic because of the salt hydrolysis. So this process is called salt hydrolysis because the negative ion of KF reacted with water and it produced OH minus, which means that the solution is going to be basic. All right, so that happens when you have a strong base and a weak acid. Your solution is going to be basic. All right, now let's go to salts that produce acidic solutions. An example of that would be NH4Cl salt. Okay, that happens between a reaction that happens from a reaction between a weak base, look now, weak base and strong acid. Okay, now I will not put water here, so when there's a reaction between weak base and a strong acid, which are NH3 and HCl, this salt is going to be produced. I'm not showing water here. And when we dissolve this in water, you will get positive and negative ions. Now, one of these is going to react with water, okay, in salt hydrolysis. So salt hydrolysis means that one of these positive and negative ions will react with water. And we find here that the Cl negative ions don't react with water. So NH4 positive or ammonium will react with water and it's going to be a weak acid, weak Bronsted Lowry acid. It means this one is going to give H2O. And look what is produced here. Okay? H3O positive or H plus. What does that mean? And you already know this from the previous lessons. When you have more H3O positive it means that the solution is more acidic and the pH is going to be below 7. All right? And this happens when you have a salt coming from weak base and a strong acid. Okay? Now there are some salts that don't produce either H plus or OH minus in the solution and they produce neutral solution. For example, neutral solutions. Sodium nitrate. Sodium nitrate is produced from the reaction between strong acid and strong base. So all of you know this reaction by now. Plus HNO3, you will get NaNO3 plus water. So this is the salt. Okay, now because we have a strong acid and a strong base, all right, the equivalence point here, or the pH of the solution, is going to be around 7. It will be neutral. Why? Because little or no salt hydrolysis occurs because Na positive and NO3 negative, they don't react with water. So they will not react with water. They will not increase H plus or increase OH minus concentrations. That's why the solution is going to be neutral. Okay, so remember that. It's very important. Now we finished. So the only thing we still have in here is in page 148. And now this is the last part of salt hydrolysis and deals with the problems that you have in page 148 in your Inspire chemistry book. Okay, so the question says write equations for salt hydrolysis reactions occurring when these salts in A, B, C, D are dissolved in water, and we need to classify each as acidic, basic, or neutral. Okay, you need to keep in mind that K plus Cl minus NO3 minus Na positive, they don't react with water. They don't react with water. Okay, because we saw them previously in the last slides. So NH4NO3 is ammonium nitrate and potassium sulfate is K2SO4. So in here you should know that NH4 plus is going to react with water because NO3 minus will not. This one will give H2 water and it will produce H3O plus, and the solution is going to be acidic. Now, potassium sulfate, K, does not react with water. So the sulfate, SO4 negative 2, will react with water and it's going to produce or get an H from water, producing OH minus and HSO4 negative. And in the book, they classify this solution as neutral, probably because this HSO4, okay, is going to further dissolve. HSO4 minus will dissolve further to give you H plus and SO4 minus 2. Okay, so basically that's why, because you'll have H plus and OH minus, so the effect is going to be neutral, and that's why they said the solution is neutral. So you should remember this example. Now RbCH3COO, which is rubidium acetate. Let me pick here 1 second. So yeah, rubidium acetate, and calcium carbonate is CaCO3. Now, rubidium acetate, you should now learn that CH3COO minus is going to react with water, okay, and it will produce OH minus, okay, and the solution here is going to be basic. Now, also in calcium carbonate, the Ca will not react, the CO3 is going to react, and it will react with water. It's going to get an H from water, like Bronsted-Lowry acid-base reactions, okay, if you remember from lesson 1 and 2, producing OH minus, the solution is going to be basic. Now, I don't know here why they said neutral, probably because of this, but it should be basic, but maybe it has to do with HSO4 minus. But remember this example of SO4 minus 2 is going to give you a neutral solution. We can discuss this further in the class, inshallah. Now, the challenge, you can do it on your own, and the solution is right here. Let's go to the last part. It says, in what process do anions of dissociate salt accept hydrogen ions from water, or cations of the salt donate hydrogen ions to water? Of course, it's not buffering. Of course, it's not titration. Of course, it's not neutralization. The correct answer is salt hydrolysis. Okay?